Hello and welcome to this video with Pandas, where we'll go into actually reading from an Excel file. And similar is when we're reading from CSV file later on. But now we will work with Excel file and you will see how that works. So before moving on to Visual Studio Code, let's move on to the browser. So here in the browser, I'm inside of Kaggle. So this web page is provided in the lecture notes that you can find. So when you're going in there, you should download this, click on the download button and also register if you're not registered. Otherwise, just sign in and download it. You will get a zip file and just unzip it and take out the Excel file. When downloading this, you will get both an Excel file and a CSV file. So you can see this is the CSV file here. And we will actually go into the Excel file here because you will later on work with CSV files a lot. So don't worry, you will learn how to use both of them. So let's move on to Visual Studio Code here. So here I put in the data. I put in calories.xlsx. So let's read that in. So read Excel. I'll choose the kernel. So here I have my virtual environment. I have installed IPyKernel. I have installed Pandas. That's it. The rest will install together. So import Pandas as PD. Let's change this to Python here. So import, we'll need matplotlib as well. .pyplot as PLT. And we'll also need something else called Seaborn as SNS. So Seaborn is used for plotting, and it's very good for plotting data frames. So let's install that. UV pip install matplotlib and Seaborn. So now we can read this df.pd. df equals pd.read Excel. Let's read, let's see. We need to find the path to this. So in Jupyter Notebook is quite easy. It's relative to where the Jupyter Notebook is. So the Jupyter Notebook is here. So relative to the data is sibling to this notebook file. So you just type data and you go inside of data using slash and you find this calories.xlsx like this. So then you can do df.head to find the head of it, to find the first rows. However, this will generate an error, as you'll see. Well, the first time takes a little time. Okay, so it says missing optional dependency OpenPyXL. So use pip or conda to install OpenPyXL. Let's do that. UV pip install OpenPyXL like this. Done. So let's rerun this cell. Yes, and it works. So what it does is that whenever you don't specify which sheet, it will pick the first sheet. So we can go into this Excel file to look how it looks like. It actually only has one sheet. And you can see that it's tabular form in Excel is a tabular format, right? And similarly, when you read it into a data frame, it's a tabular format. And using df.head, we get the head of it. We could do df.head of 10 and we get just 10 rows. We could do df.tail 5 to get the last 5 rows. That's a little bit about df head and tails. So we can usually when I start to read in some Excel file or CSV file, I want to understand the dataset, right? And to understand it, you usually do some kind of exploratory data analysis. However, I won't do a complete EDA here. I will just start a little bit so that you can see how I'm working with it. Later on, we'll go into more depth into EDAs. So let's do df.info to get some info. So you can see the data frame is an instance of the Pandas data frame class, right? And in this instance, it has a method called info. That's why we have parentheses. So tail is a method, head is a method, info is a method. So now you see how good it was that you have studied some OOP, so you understand how different types of libraries work. So df.info, we use this method, and let's see what it happens. We see here, this is the wrapper of this or not the wrapper. It is actually df.info prints this out, right? So you can see here range index. I will actually zoom in a little bit here, and I'll remove this one as well. So you can see, I can zoom in one more time to make it even simpler. So we have here, we can see they have different columns and how many counts of them, non-null. So that if you see that the sum are a little bit smaller than the number of entries, then you know that we have nulls. And we see the data types. They have object as data type, and object is the most general data type. So usually when you have strings, it's represented as objects. When you have list, you have dictionary, it's represented as objects. But however, if you see here, for example, per 100 grams, we say 100 G. So the G makes it a string. So Pandas infers it as strings when we're reading this into a data frame. So that's why we have object data type. However, with object data types, we cannot do addition, subtraction. We cannot do arithmetic operations on it. So we need to change it to other data types, right? We need to cast it to another data type. So for example, here we can cast it to integers. This one can also be casted to integers, and this one as well, so that we can do some summary statistics on it, for example. So moving on here, we can check out the df food category. So this is this column, right? So if we do this, we get a series of 2,225. Oh, sorry, if you heard that, it's when I said series, my iPhone reacted because they thought, hey Siri. Okay, sorry for that. So df food category, you can see all the different food categories, and you can see it's repeated, right? So we could find out how many there are. We can do .unique. And if you just do .unique like this, you see, bound method series. So it's a method, so you need to call it using parentheses. So here is the array of all the unique values, right, in this food category. So moving on here, we can find out df, for example. Yeah, we could do this one, for example, and do unique here as well. Because I want to know if there's any. Yeah, let's do that. So we have 100 G and 100 ml, so milliliters. Okay, so now we know that, okay, this per 100 grams is not just G, it's also for liquids, right? Because when you have liquid, you use 100 mil as a reference instead of 100 gram. Okay, so let's do some. As I said before, I won't go into more exploratory data analysis. Instead, we'll do some. And what type of data cleaning do we want? We should have a strategy for what we're doing. So my strategy is like this. We notice that all data types are object. We need to typecast to int. So type as object to int. For a few rows, for a few columns, or the columns that you want to count on. We can, for example, we can convert else. So I want to change column names. I want to convert cals per 100 grams to int. And I want to separate liquids and solid to different DFs. So that is my strategy. So usually what type of strategy you want to have is based on what your goal is, and also it's based on what so usually as a data analyst or a data scientist or data engineer or some similar roles, it's not sure that you're the one deciding always. Instead, you should work closely with the domain expertise. So you should talk with the domain expert. What is it that you want to be able to show? What is the goal? For example, a goal could be a graph. It could be a dashboard. It could be some analysis of some sort. So you talk to the different stakeholders, you talk to your team and the domain experts, right? But here, let's say that we want to have this. So let's do it like this, df.rename. We can rename. And when we're renaming, we should use a dictionary of the current columns. So in order for that, I will create a new code here, and I will just do df.columns to see what type of columns we have. We have food category, food item, etc. I want to change. I want to do like this, a dictionary, cals per 100 grams. I want to change it to calories. I want to change per 100 grams as per 100. I want to change kilojoule per 100 grams. I want it to be kilojoules. Okay, like this. And in order to auto format, I use Shift Alt F or Shift Option F. And I run this one. And you can see that, oh, nothing happens. Okay, why? Because rename, if you look into the documentation here by hovering it, so it renames columns or index labels. And you can see the axis need to be defined. So if you look down a little bit here, you can see axis 0 or index, 1 or columns. So now we're trying to change the indices. However, the indices don't have any of these values, right? So we need to specify. We can do index or axis equals to columns, or axis equals to 1. That is equivalent. So if I run this one, you can see that the name has been changed. We have renamed it. Perfect. However, if I run df now, df.head, for example, we can see that, it hasn't persisted. And why is that? That is because, note that we're not mutating the data frame. We're getting a new data frame back. And in order for us to actually mutate it, there's some special method for doing that, or some special option for doing that, or we should assign it to df itself. So let's copy this one. And we say df equals to this. So now we have reassigned df with the new names, right? So if I do df.head, we can see that it works. It's the new names. Okay. So now you know that we have, so you should always reassign it in order for the changes to take place, right? Or there's usually some method called some option called in place equals true, which can also be used. So let's continue now. So our strategies, we wanted to change the calories, right? So df calories. So you can see we have cal here. and we have a space. So this seems to be the pattern. So how to do this? It's quite simple. We could just do string slicing if this is the case. So if we're doing string slicing, if you could do like this, :-3, and then you get everything except the 3 last ones, right? But that this one doesn't really work. So this one is normal slicing from 0 to the last 3 items. That's why we have 2, 2, 2 instead of 2, 2, 4, I think. So what you need to do is you need to do .string. So by doing .string, you're accessing this property. So property we haven't actually talked about in the OOP, but this is a method which you have used a decorator, so that you've given the method another functionality, which becomes a property, and a property you access it by doing dot notation without the parentheses, right? So with this property, you can use this as a string, normal string, but what it's different is that this will work element-wise. It will work on each of the element. And note one thing, I'm usually always using the data frame methods or the data frame properties or attributes. I will almost never loop through a data frame. And that is because looping through a data frame is really slow. You should instead use the methods inside of the data frame API itself. That is because when you're doing that, pandas can use something called vectorization and a lot of optimizations in order to make the performance much faster. So in general, never loop through a data frame. Sometimes you might need to loop through a few values, but that is okay, but not much. Okay? So let's do this. Now we can see the calories has disappeared. Okay. Can I then change it to int.asType int? And you can see it worked. The D type is int64. However, same idea as before. For example, if I do df calories.head, this is the series, right? And you can see it hasn't changed. So I should copy this one and reassign it. So let's do that. So we have df calories equals to df.head. And you can see that it has changed. We have reassigned it so that we have a new data frame where we have fixed the calories. So let's continue now. I want to divide the solids and liquids. Actually, we could continue with kilojoules and per 100 gram, but I will leave it for the readers. So I won't take away all the fun for you. So let's do like this. df per 100. And we can see a lot of 100 grams. We should do .value count. And this will count. If you know SQL, it's similar to group by, and then you do count. So you're doing an aggregation of each unique values here. And you can see here, okay, the unique values were 100 G and 100 ml. And you can see the number of entries for each, number of rows corresponding to each of them. Cool. Let's continue now. Let's continue with this. For example, if I want to pick out all the liquids, I should do like this. df per 100 equals to 100 ml. So then we get a lot of false and true. So now I've gotten a Boolean mask, right? This is a mask. And using this mask, I could pick out all the rows corresponding to this mask. corresponding to where it's true, right? So df of this Boolean mask, we get all the values or all the rows corresponding to 100 ml, right? So corresponding to liquids. And you can see here 423 per 100 grams, right? Value counts per, and you can see 423. So great. This one, we should reassign it. So I will have liquids here equals to this, and I can do liquids dot to get the first file. And I will do similar for solids. However, I will use the query syntax, which I showed you in the last lecture. So df.query, we want to query per 100 gram. This is the column, right? And we should do equal and a string 100 G. And this is only those corresponding to the solids, right? So 1802, we have 1802 here. Cool. So solids equals to this one, solids.head. And you can see here are the solids. Okay, moving on now. Let's find out something. We can find out some KPIs, it's called. We'll come back to KPIs later on in this lecture series. But here, a KPI, it could be find out top 5 categories with highest calories. So in order to do this, we can do a sorting. So we could have solids dot sort values, and we can have by which column do you want to sort on. I want to sort on calories, and you can see that it's sorted on calories. It's possible to sort on calories because we changed it to integers, right? And now you can see that the last 5 here are the ones we wanted, but they are in ascending order now. We should change it to descending order. So ascending equals false. So now it's descending, and you can see these are the top 5. Okay, soups. Maybe that should have been liquids. However, you should know that the data set, there might be errors in it. So that's why it's important for you to understand the dataset you're working with, and you show it to your domain expertise. Maybe the domain expertise says that this soup should be a solid or it should be a liquid. Then if that person has said that, then you can change it, or you can move it to the other category, for example. So it's important to understand the dataset and not just work with it blindly. However, we'll leave it like this. So let's do like this. We have solids and we have sorted, right? So solids sorted equals to this, and we can do solids sorted dot head to get the top 5, right? Since we have seen head, I'll show you another one, ILOC. So this is index location. So we're indexing based on where it is. So it doesn't matter that this index is called 1621. When you do ILOC, you start this with 0 anyway. So 0, 1, 2, 3, 4, 5. So if I do colon 5, then I will get the same result. So this is Python way of slicing. So we're getting the solids top 5. Moving on, we can do similar for liquids. So liquids top 5 equals to liquids dot sort values by calories, ascending equals false. Liquids top 5, and you can see, we didn't take the top 5, but if I do dot head here, we get the top 5. Okay, so let's do some small calculations here. For example, I could do like this. df.group by. I want to group by all the food categories. what did we do? We got to get the 5 top categories with highest calories. We looked into solids by itself. We looked into liquids by itself, but now we will look into both of them together. So what I can do is that I could group by food category. So then I will get, it says generic data frame group by object. So this is just an object living in a memory place. So by getting something from this group by, we need to combine it with an aggregation method, right? So what can we do? I will pick out the calories. And now we get a generic series group by. That didn't help so much, but we take an aggregation, a median, for example. So aggregation function or method in this case means that we have a lot of, it's a many-to-one transformation, many-to-one mapping. So we have many values. The output is one value, right? So we get the median. And it's one value per food category. So if I run this one, we can see, each food category, we get the median calorie. Okay. So let's continue here. Let's sort this. So sort values. Okay, so why can I do like this? Because this returns a series object, and a series object, we have a sort values. So that's why I can nest the methods. So I can chain the methods. I do one method after another because it returns either a series or a data frame. So this is a very good way to work with pandas. Sort values by equals calories. They don't have a by because they only have values here, right? So sort values, and then we get it ascending, and we do a equals false. So then we have descending, and now we just take dot iloc colon 5, and then we get the top 5. And now we could do, now this is a series object, right? So we can do dot reset index. So we get indices of them, and it becomes a data frame object again. So now we have the data frames of the top 5. Actually, it's not correct. If you see here, vegetable oils 885. It's not really correct. How come? As we do iloc here, we do sort values, reset index. Or it is correct. So it takes the median, right? So there's, for example, vegetable oils. We have several vegetable oils, right? So for example, here, wet germ oil, or this cod liver oil, it has 1000 calories. However, in the median, you order all of them and you take out the middle value or the middle 2 value and divide it by 2. So this is correct. So we can call it top 5 category equals to this, top 5 category. And let's continue with some plotting now. So I want to plot this. So for example, in order to plot it, I could do sns.barplot. And I will put in data equals to top 5 categories, for example. And we choose here X. Which column is that? X should be food category. Food category. And Y equals to calories. So basically here I have a plot, and you can see this is quite ugly here. It should be changed. However, this is a simple way to plot using Seaborn. And what you need to put in is the data, is a data frame, and you choose which is the X column, which is the Y column. So this is how simple plotting using Seaborn works. And you can see it looks really similar to Matplotlib. And that is because it used Matplotlib in the backend. Okay, so now I want to plot several of my plots. I want to plot them all at once. And what I usually see a lot of people do is that they just copy and paste this code 3 times and do a lot of settings. Don't do that. Instead, you can use looping. So just do an iteration using for loop. And I can show you how to do that. So fig, axis equals to plt.subplots 1,3. We can choose the dpi dots per inches 120. Fig size equals to 16,4. Then you get 3 plot windows. And this you can change yourself to find out which one fits for you. And then we can take out some titles. Equals to, I can have solid, top 5, I can have liquids, top 5, and let's have some top 5 per group. Median. Okay, now we're working with different, I'm using lists, and you can see we have 3 items, right? 3 elements in these titles. So that means that we're going to loop through it. What else do we want to loop through? We want to loop through our data frames, right? So then we can just create a list of our data frames. So data frames equals to solids, top 5. We have liquids, top 5, and we have top 5 category, right? So now we have, for example, if I write out data frames, we can see it's a list of data frames. And if we want to take the 0th, we get the 0th data frame. So yeah, that is a very good advantage of using list. List, you can actually put in different data types. You can put in different objects. That's no problems. So let's use that to our advantage. X columns. So we want to have food item. Let's see, food item, comma, food category. Because it's, if you remember, they have food category in the categories, while the other ones are food items. So now, when we have this, let's loop. So for x, comma, data, comma, title, comma, x column, in zip. And when we're doing zip, we're taking all of these 3 here, and the axis, all of these 4. And then we pick out, so that we get first title, we get first X, we get first data frame, we get first X columns. And then we get the second, the third. So let's do that. Axis, comma, data frames, comma, titles, comma, X columns. Like this. And we do plot, sns.bar plot. Data equals to data, because we will get each of the data here. X equals to X column. We'll get each of the X column. What else do we have? We have Y equals to calories. I'm using calories here because calories are common for all of them. And it's the one we want to plot. X equal to X. So we plot on which window, right? On which X here. And then we do x.set title equals to title. Like this. Run it, and we can see here's our plot. It's quite ugly here that it's quite crowded. So let's just rotate it. So we can do x.set xtick labels. And this actually needs to have, it's strange, but it's just how it works. So you get the xtick labels, and this is so that you get these labels, and then you do a rotation of it. So rotation equals 90. Okay, and there's some user warning here, but we can ignore that. So now you see it's rotated. Okay, perfect. And soon finished. Let's do fig.savefig. And we can save it to, for example, figures/calories.png. Let's do like this, run it, and there is find not found because there is no figures. So let's just create and make the figures like this. So then if I run this one, now it has saved in the figures folder. And we have these calories. Okay, it's clipped out here, so let's fix that. With an option here, we can do bbox inches equals height. If I run this one, we can see that, yeah, it will fit this. It will fit everything with the box. Okay, but we will come back with a lot of plotting later on. Don't worry if this seems quite new for you, but we'll plot a lot in this course. But thank you for watching this and you learned about the data frames and reading in Excel files and processing it. Thank you for watching this video and see you in the next one. Bye.